In this video, I'm going to find the area of this rectangle, the largest area that can be contained under the line y is equal to 16 and the parabola. So the way we do it is by using derivatives. We define the function, we take the derivative, set it equal to 0 so that we can find the critical points, and then we evaluate the value of the function at the critical points as well as on the boundary points. Then we take the maximum of it. So let's find the area of this rectangle. So let's say my area is a of x, area as a function of x, which is going to be length times height. So in our case, this is x and this is also x, the length itself. So this total length of the rectangle is going to be 2x, and then height is going to be just this height. Now, how do I find that height? By the way, so think this height is going to be 16 minus this little height, okay? So 16 is here, right? So this horizontal line is 16. So this is going to be 16 minus the height. So at this point, the height is going to be y, right? So it's going to be 16 minus y, which is y is equal to x squared, because this is a parabola, right? Y is equal to x squared. So it's going to be 16 minus x squared. Now, this is my function. And if I can simplify it, I'm going to get this 32x minus 2x cubed. So this function we need to take the derivative of. Here I take the derivative and set it equal to 0. So the derivative of 32x is just 32. Derivative of 2x cubed is 6x squared using the power rule. Then I just try to solve for x, and finally upon some simplification, as you can see here, I get this. However, we exclude the negative value because the length is positive. So we take our critical value x to be 4 over square root of 3. Now we are going to have to evaluate this function at this critical point as well as the boundary points. So for x, the boundary points we need to remember, x can go between only 0 and 4 because the horizontal line y is equal to 16, that puts an upper limit on x, right? So 0 is less than equal to x is less than equal to 4. So my boundary points are going to be x is equal to 0 and x is equal to 4. Now note that if I plug in x equal to 0 to this function, I'm going to get a of 0 is equal to just 0, because this is 0, this is 0. And also, if I put x equal to 4, so a of 4 is also going to be 0. Why? 4, you can just look at this version of the formula or equation. X is equal to 4 means x squared is equal to 16. So 16 minus 16 is 0. So in both of these cases, it's 0. Now let me go ahead and do the calculation when x is equal to 4 over square root of 3. Remember that x is equal to 4 over square root of 3. It's a critical point, right? Where the derivative was 0. So we just plug it in here for x. So I'm using this version of the equation. So 32 times 4 over square root of 3 minus 2 times 4 over square root of 3 cubed. So I just simplify it here, as you can see. And then this, so only thing is that here I break it down into square root of 3 square times square root of 3. So that square and square root cancel out. That gives me 3. And then I just combine this term and this term by subtracting. And this is what I get. And ultimately, my result is 256 over 3 times square root of 3. So my a of 4 times square root of 3 is 256 over 3 times square root of 3. Now look at all the different values we got at the boundaries and critical points. So we have only one critical point, remember. So at the boundary, the area is 0 for both the boundaries when x equal to 0 and x equal to 4. But at the critical point, the area is 256 divided by 3 times square root of 3. And that's the largest value among all the values that we have considered. So therefore, the area of this rectangle that is going to be contained between this horizontal line y is equal to 16 and the parabola in the upper half of the coordinate system will have the maximum area of 256 divided by 3 times square root of 3. I hope that this discussion was helpful. Thank you very much.